Determine if each of the following radical expressions is a real number. If it is, evaluate the expression. The first example, or the A, for example 1, we are going to determine if each of the following radical expressions is a real number. If it is, evaluate the expression. In part A, we have the number negative square root 9. Square root 9, the index is 2. The radicand is greater than or equal to 0. So then we can determine the value as negative 3, which is the real number. The second one, or part B, the square root of square root 9, n, or the index is 2, which is an even number. The radicand is less than 0, so no such real number that satisfy this expression. In part C, we have the cube root of negative 27. The cube root, the index n equals 3, which is an odd number. So then the radicand can be either positive or negative number. Therefore, the answer gonna be some number that raised to the power 3 equals negative 27. The answer is negative 3. Which I'm gonna put a note over here because negative 27 equals negative 3 quantity raised to the third power, which means negative 3 times negative 3 times negative 3 equals negative 27. And the last one, the fourth root of 625 divided by 81, use the property that when we have the n root of the quotient is the quotient of the n root. So we can rewrite it as the fourth root of 625 divided by the fourth root of 81, and then evaluate each one of them. If we look at the index is 4. The 4 is an even number. The 625 and 81, both of them are positive number. Therefore, we can evaluate or we can find a real number that satisfies this expression. So let's go ahead. The fourth root of 625, that means some number raised to the fourth power equals 625, which means that number is 5. 5 to the fourth equals 625. Similar to 81, the value 3 raised to the fourth equals 81. So then the answer for part D gonna be 5 for the numerator and 3 for the denominator. So then 5 over 3 is the answer for part D. Next example, we are going to simplify the following radical expressions. Keep in mind, we're going to stick with the property that the n root of the a to the power n equals absolute value of the a for n as an even number. The n root of a to the power n equals a for n as an odd number or the odd natural number. For part A, we have the square root of 121 x squared times y. The index of the root is 2. Put a note here, n equals 2 or the square root. Therefore, we have to make sure that all of them, all the radicand factor must be greater than or equal to 0. So one, and then use the property of the radical of the product is the product of the quantity. So we have square root 121 multiplied by square root of x squared multiplied by square root of the y. For the number 121, 11 raised to the second power is 121. So then for the number portion, we have the result as 11. And then since this is the even integer index So then the square root of x squared will become absolute value of the x, where the square root of y has no change. Now we have the simplified radical expression for part A as 11 times absolute value of the x times square root y. To simplify the fourth root of x to the 8 times y to the 12 divided by 16, we use the property that the n root of the quotient is the quotient of the n root. The n root of the product is the product of the n root. So we can rewrite it as the fourth root of x to the power 8 times the fourth root of y to the 12, all divided by the fourth root of 16, and then break it up the power of x, y into the multiple of the 4 and remainder. So for the x to the power 8 is x to the 4th times x to the 4th. Y to the 12 is y to the 4th times y to the 4th times y to the 4th, where 16 is 2 times 2 times 2 times 2 times 2, which is 2 to the 4th power. At the fourth root of x to the 4th times the fourth root of x to the 4th times the fourth root of y to the 4th, fourth root of y to the 4th, and the fourth root of y to the 4th, all divided by the fourth root of 2 to the 4th. And then each one of them, we use the property that the n root of a to the n equals absolute value of a, where n is an even natural number. Since n equals 4, which is the even natural number, so then each one of them becomes in the absolute value form, the absolute value of the x multiplied by absolute value of the x multiplied by absolute value of y times absolute value of the y and y, and all divided by absolute value of the 2. And then we just simplify one more time to get the final answer. Absolute value of the x times absolute value of x, just x squared, because when you have the number of the factors as an even number, so the negative side will disappear. Where for the y term, so we have to be careful. So you can write it as y squared times absolute value of y, and then divided by 2 because 2 is already positive. For example C, we are going to simplify the cube root of 64 times x to the 5th times y to the 28th. We will apply the property that the cube root, the n root of the product is the product of the n root. And we write it as the third root of 64 times the third root of x to the 5th times the third root of y to the 28th. And then write each one in the quantity raised to the power of 3 or the multiple of the 3. For example, the 64, if we break it down, it's 4 times 4 times 4, which is 4 to the third power. For x to the 5th, write it as the multiple of the 3. So we have one factor of the 3, and then the leftover power would be the power 2. For y to the 20th, the multiple of the 3 closest to the 20 is 18. So that means we can make it up as y to the third times y to the third times y to the third times y to the third. There's 6 of them. And then the last factor would be the remaining, which is 2. So 3 plus 3 plus 3 plus 3 plus 3 plus 3, the total like 18, and plus 2 becomes 20. So this way, we can see how many factors that we can simplify out from the cube root. So the first one, it becomes the cube root of 4 to the third times the cube root of x to the third, the cube root of x to the second, and for the y factor is gonna be 6 factors of y, the cube root of y to the third. And then the last one is the cube root of y to the second. For this case, the index n is an odd number. So then we do not have to put the absolute value for the result of each factor. So we have the first one as 4, and the next is x, and then the cube root of x to the second, and then we have y times y times y times y times y times y, and times the cube root of y to the second. So we can write it as the final form for x, the cube root of x to the second, and then 6 factor the y, so y to the 6 times the cube root of y to the second.